Hi, my name is Steve Motton, Technical Architect at FlexManage, and today I'm here to talk to you about Azure StorSimple Virtual Array operational best practices. Microsoft Azure StorSimple is an integrated storage solution that manages on-premise storage between Microsoft Azure cloud storage. The Microsoft Azure StorSimple Virtual Array is an integrated storage solution that manages storage tasks between on-premise virtual devices running in a hypervisor and Microsoft Azure cloud storage. The virtual array, also known as StorSimple on-premise virtual device, is an effective cost solution and easily manageable file server or iSCSI storage solution that eliminates many of the issues and expenses associated with the enterprise storage and data protection. The virtual array supports the iSCSI and SMB protocols and runs on existing hypervisor infrastructure and provides tiering to the cloud, cloud backup, fast restore, item level recovery, and disaster recovery features. So let's look at some of the operational best practices. We start off with backups, restore, failover and disaster recovery, deactivate, monitoring, index search and virus scan of applications, byte range logging. So let's start with backups. The data on your virtual array is backed up to the cloud in two ways. A default automated daily backup of the entire device or via a manual or on-demand backup. By default, the device automatically creates daily cloud snapshots of all the data residing on it. When configuring the start times for automated backups, we recommend the following. Schedule your backups for off-peak hours, as backup start time should not coincide with the hypervisor host. Initiate a manual on-demand backup when planning to perform a device failover or prior to the maintenance window to protect the data on your virtual array. Next, we'll look at the restore option. You can restore from a backup in two ways. Restore to another volume or share, or perform an item level recovery. When performing a restore, keep in mind the following best practices. Your StorSimple Virtual Array does not support in-place restore. This can, however, be readily available in a two-step process. Make space on the virtual array and then restore to another volume or share. When restoring from a local volume, keep in mind that the restore will be a long-running operation. 3. The volume type remains the same during the restore process. A tiered volume is restored to another tiered volume and a locally pinned volume to another locally pinned volume. And 4. When trying to restore a volume or share from a backup, if the restore job fails, a target volume or share may still be created in the portal. So it's important that you delete this unused target volume or share in the portal to minimize any future issues that may arise from this element. Next, we have the failover and disaster recovery. A device failover allows you to migrate your data from a source device in the data center to another target device located in the same or different geographical location. The device failover is for the entire device. During failover, the cloud data for the source device changes ownership to that target device. For your StorSimple Virtual Array, you can only failover to another device. When performing a failover from your virtual array, keep in mind the following. For a planned failover, it's recommended best practice to take all the volume shares offline prior to initiating the failover. For a server disaster recovery, we recommend that you join the target device to the same domain as the source so that the share permissions are automatically resolved. Once the DR is successfully completed, the source device is automatically deleted. Though the device is no longer available, the virtual machine that you provision in the host system is still consuming resources. So we recommend that you delete this virtual device from your host system to prevent any charges occurring in Azure. Do note that if a failover is unsuccessful, the data is always safe in the cloud. Consider the following 3 scenarios in which the failover did not complete successfully. Number 1, a failover occurred in the initial stages of the failover, as when the DR pre-checks are being performed. In this situation, your target device is still available. You can retry the failover on the same target device. A failover occurred during the actual failover process. In this case, the target device is marked unusable. You must provision and configure another target virtual array and use that for failover. The failover has completed the failover process to the source. The device was deleted, but the target device has issues that you cannot access any data. The data is still safe in the cloud and you can easily be retrieved by creating another virtual array and then using it in a target device for the DR. Our next best practice is we have the deactivate function. When you deactivate a StorSimple Virtual Array, you sever the connection between the device and the corresponding StorSimple Manager service. Deactivation is a permanent function and cannot be undone. A deactivated device cannot be registered with the StorSimple Manager service again. So let's keep in mind the following best practices when looking at deactivating a StorSimple Virtual Array. Take a cloud snapshot of all the data prior to deactivating the virtual device. When you deactivate a virtual array, all the local device data is lost. Taking a cloud snapshot will allow you to recover data at a later date. Before you deactivate a StorSimple Virtual Array, be sure to disconnect all the clients and hosts that are using that device at that time. Delete and deactivate a device if you are no longer using it so that there are no Azure charges. Next, let's discuss monitoring best practices. To ensure that your StorSimple Virtual Array is continuously in a healthy state, you need to monitor the array and ensure that you receive information from the system, including alerts. To monitor the overall health of the virtual array, consider the following. Configure monitoring to track the disk usage of your virtual array, data disk, as well as the OS disk. If running Hyper-V, you can use a combination of Virtual Machine Manager or System Center Configuration Manager. If you're running Hyper-V, you can use a combination of Virtual Machine Manager or System Center Operations Manager. Configure email notifications on your virtual array to send alerts at certain usage levels. Also, when discussing operational best practices, let's look at the following. Index search and virus scan applications. A StorSimple Virtual Array can automatically tier data from the local array to the Azure cloud. When an application such as an index search or a virus scan is used to scan the data stored on StorSimple, you need to take care that the cloud does not get access and pull data back into the local tier. We recommend you implement the following best practices when configuring the index search or virus scan on your virtual array. Disable any automatically configured scan operations. For tiered volumes, configure the index search or virus scan applications to perform an incremental scan. This will scan only the new data likely residing in the local tier. That data is tiered to the cloud, is not accessed during an incremental operation. Ensure the correct filters and settings are configured so that only the intended types of files get scanned. For example, image files, JPEGs, GIFs, TIFFs, and engineering drawings should not be scanned during incremental or full index rebuilds. If you're using the Windows indexing process, follow these guidelines. Do not use Windows indexing for tiered volumes, as it recalls large amounts of data from the cloud if the indexing needs to be rebuilt. Rebuilding the index would retrieve all file types to index their content. Use the following index process for locally pinned volumes, as this would only access data on the local tiers to build the index. The cloud data will not be scanned. Here are some measures to alleviate byte range locking. Applications can lock a specific range of bytes within the files. If byte range locking is enabled on the applications that are writing to your StorSimple device, then tiering does not work on your virtual array. For the tiering to work, all areas of the files that need to be accessed should be unlocked. Byte range locking is not supported with tiered volumes on your virtual array. This concludes our presentation on StorSimple Virtual Array and operational best practices. Thank you for watching today's presentation on StorSimple Virtual Array operational best practices. You can contact me, Steve Motton, at smotton@flexmanage.com.